Hello and welcome to Algebra 2 tutorial. In this video we're going to take a look at polynomial factoring. Factoring is a big part of algebra. We usually do it with trinomials and quadratics, but now we're going to extend that to our larger polynomials that we have been working with. First though, let's take a look and make sure we understand what factoring actually looks like and why we're doing it. So we have two different forms of polynomial equations. This first one is the one we've been working with the most, when we call that standard form. We usually try to have the highest power of x first, and then it goes in descending order until there are no more x's left. And here I just have an example of a cubic, but that could be any power bigger than 3 or smaller than 3, and then we put them in descending order. So you can see I've got 4 terms and they're all adding, or they could be subtracting. But we can also write that as factored form. And so if we can get the equation to look like this, x minus a number in parentheses, then multiplying times x minus a number times x minus a number. Depending on how many factors you have, this would be a cubic over here. That is oftentimes very useful, because these show us our x-intercepts. And so if we want to know something about the graph, this is very useful because we can see all of the x-intercepts right here. It was very useful when we did quadratics. So how can we extend this to larger polynomials and not just quadratics? So that's our goal here today that we are going to try to do. So there's a couple of different methods of factoring that we're going to look at. So 3 in fact. The GCF first, then factor by grouping, and then just checking random factors that we think will work are the 3 we're going to take a look at in this video. So first, the GCF. So when you get a polynomial, here we have a trinomial, you can take a look at all the terms individually and see, do they have something in common that we can divide out, that we can pull out, factor out. And if I take a look at these 3 terms, they all have a 2 in common, so I can divide them all by 2, and they all have an x squared in common, which means they have at least an x squared in them. And so I can factor that out by dividing each one by this 2x squared. So if I take a 2x squared out of this one, we are left with x squared. And if I take a 2x squared out of this one, we will be left with a 3x. And then if I take a 2x squared out of this one, 56 divided by 2 is 28. And if we take away the x squared and pull it out here, there are no more x's left. So we started factoring that. It's already looking a little bit better. We have some multiplication, we have parentheses. But we should try to go one step further, because this trinomial that's left looks very familiar. We've done factoring with these a lot. So we ask ourselves, what multiplies to be 28 and adds to be 3? I think 7 and 4 will do it if the 4 is negative. So we can factor what's left over to be x plus 7 and x minus 4. All right, and so there is our factored form. This one works out really nicely. That won't always be the case, but I wanted to show you one that worked out really well. We even have a look at our x-intercepts. This x will give us 0 as an x-intercept. This one will give us negative 7. And this one will give us positive 4. All right, so that's our first strategy. If you can pull out the GCF first. So now we're going to take a look at factoring by grouping. That was one of the methods of factoring a trinomial, which is why it was good that we looked at it a while ago. But here we have 4 terms, and that's what gives you an idea that grouping might work. So I'm going to group these terms, and I'm going to do that by splitting them in half. And so I'm going to group these 2 together, and I'm going to group those 2 together. And I take a look at these 2 terms. What do they have in common? What can I factor out? What GCF do they have? Looks like I can divide them both by 2x squared. Now what's left over once I do that? I'll have 3x plus, and 10 divided by 2 is 5, and the x squareds all come out. Now I'm going to do the same thing to the other side. What does the 9x and the 15 have in common? It looks like they have a positive 3 in common. So what's left over? 3x plus 5. And here, there was a coincidence. This is the same as that. And that means we can keep going. If they weren't the same, then grouping failed. But in this case, it worked out, so we can continue factoring. Now this is the weird part. So over here, we pulled out an x squared because it was in common. There's an x squared inside this and an x squared over here, and we pulled it out to the front. And that's exactly what we are going to do with the parentheses. We have a big term over here, and it has a 3x plus 5. And we have a big term over here, and it also has a 3x plus 5. And so we're going to take those and pull them out, factor them out. So it goes to the front, 3x plus 5. Now what is left over? If I take out the 3x plus 5, the only thing that's left is 2x squared. And if I take out the 3x plus 5, the only thing that's left over here is the 3. And so that is our factored form. You might try doing something with this, but that doesn't look promising to me, so we're going to leave it. And there is our factored form. If you wanted to, you could find the x-intercept here. It's negative 5/3. And this one's a little bit more difficult. It's an imaginary number, but still, we have ourselves in factored form, which was our goal. So that's grouping. One more for us to take a look at. What if we just check factors? So this is useful when you have a really big polynomial. So here we have 1, 2, 3, 4, 5 different terms. We can't use grouping. We can't pull out a GCF. They don't all have something in common. So our other two methods don't work. So we need more information. And so I graphed it over here. And if I take a look, I can see a few x-intercepts on it. Namely those two. It looks like -2 and 4 are x-intercepts. Well, if they are x-intercepts, then I think x plus 2 should be a factor, because this will give us an intercept of -2. And I think x minus 4 is also a factor, because positive 4 is an x-intercept. And yes, there is going to be some stuff left over that I don't know, but I think these two work. And so I have to test it. I'm going to check it. Well, if they are factors, here's the key. That means we can divide by them. Okay? Let me use a number as an example. What are the factors of 15? 5 and 3. 5 times 3 is equal to 15, but also I can divide 15 by 5, and I can divide 15 by 3, and it works out. And that's where we have a great strategy. If this is a factor, meaning it's a multiplication problem, I should be able to divide by this. And so I'm going to take this big polynomial and divide it by x plus 2. It's right up here. Divide it by x plus 2, and it should work out perfectly. Now that looks awful, but remember we have a great strategy for this, synthetic division. And so I'm going to use synthetic division and try to divide this into that. And remember, with synthetic division, you don't use the positive 2, you use the negative 2. You use the root, you use the x-intercept. And then you just use the coefficients, 1, -2, -18, 20, and 80. Let's see if this works. So you bring down the 1. Negative 2 times 1 is negative 2. Negative 2 and negative 2 makes negative 4. Multiply, that makes positive 8. Add, that makes negative 10. Then that makes positive 20. 20 and 20 make 40. Negative 2 times 40 is negative 80, and we get 0. Hey, look at that. It worked. That means x plus 2 is a factor. That means it does in fact cross exactly at negative 2 here on the x-axis. All right, but we also want to check this one. So we can just keep doing it with what's left over. We don't have to set up the problem again. We just try this with a 4 now and keep going. So the 1 comes down. 4 times 1 is 4. Add those together, you get 0. 4 times 0 is 0. Add those together. 4 times negative 10 is negative 40. And again, we get 0. And so this one also checks out. And the other nice thing is, once we divided those two out, the leftover right here is the leftover right here. So remember, this one is our remainder. So we have a remainder of 0, so that one doesn't matter. This is our number. And then this one will have an x, so that one's going to go away actually. And then this one has an x squared. So we are left with x squared minus 10. Let me write that a little bit better here. And here now we have our factored form. So using synthetic division, you can check a factor by dividing by it. All right, just make sure if you're going to check x plus 2, you use the negative 2. That's the one tricky thing about synthetic division. All right, so those are our 3 factoring methods that we are going to take a look at, all trying to factor those polynomials. All right, we had 3 different methods to do that. So let me give you a few practice problems to try out so you can try those 3 different methods. Good luck.